With this video, we will learn how to determine the concentration of different solutions based in molarity and molality. The concentration of a solution is the exact amount of solute that is being dissolved in a solvent. For your knowledge, concentrations are always expressed in percentages or parts per million, grams, milligrams, grams per liter, moles per kilogram, and so on. Let's begin studying molarity. Molarity is also known as molar concentration, and we can define it as the quantity of moles of solute present in every liter of solution. If we write this definition like a formula, we would do this way. Molarity equals the moles of solute by liter of solution. You have to notice that molarity has capital M. You need to learn this. In which times, where do we use molarity? We use it when we are talking about a solid solute and a liquid solvent. Like in this diagram, look, you can see this might be sodium chloride, for example, and we want to make a solution with water. So we drop this salt through this volumetric flask and then fill it with water until the volume we want to do. Let's solve this example together. Let's say we have 28 grams of sodium chloride and 350 milliliters of water. We mix them together and we want to know the concentration of this solution. By mean, what is the molarity of this solution? Well, we need to analyze all data that is being given to you and how to use it. Look, we need to remember that the formula for molarity is moles of the solute by liters of the solution. So as you can see, the data they are giving us, it's grams, 28 grams of the solute, and the volume of the solution, which is 350 milliliters, right? As you can see, none of these values correspond to those that I need in the formula. The first thing I need to do is I need to convert these grams of solute into moles, and I need to convert these milliliters into liters. Let's do the first step and then do the second one. You know how to do this. Let's calculate the molecular weight for sodium chloride. You know how to determine this calculation. Sodium has a weight of 23 grams and chlorine of 35. The molecular weight is 58 grams. I now know that 1 mole of sodium chloride corresponds to 58 grams. I don't know how many moles of this solute correspond to the 28 that's being asked in the problem. My X value now is 0.48 moles. I have solved the first part. Let's continue with the second part. From my conversion table, I know that 1 liter 1 liter equals 1000 milliliters. I don't know how many liters correspond to 350 milliliters. Doing this operation, I will get that it corresponds to 0.35 liters. And now we just need to replace the values. Remember that molarity equals moles by liter. Now I have both values, 0.48 moles by 0.35 liters. The final result is 1.37 moles per every liter. Please remember to circle every result. Let's do another example. This one says, calculate the grams of sodium hydroxide needed to prepare 250 milliliters of a 3.5 molar solution. Given 250 milliliters, this is the volume of the solution, and they are giving us the data, the molar data, which is 3.5. If you remember, the main formula is molarity equals moles by liters. Look at this. We have this value, which should be here. We need to convert it to liters, And we have this value. We have now the molarity. And they are asking us the grams. Well, in order to get the grams, we need to get the moles first. So the first thing we need to do is what? We need to solve for moles. How do you solve for moles? Let's do it. Remember, moles equals now liter by times the molarity. So let's change this value, this molarity value, to place it here, and let's convert this into liters. Okay, so first we are going to convert the milliliters. One liter equals 1000 milliliters. 250 milliliters equals 0.25 liters. Now I can replace it in the formula. Moles equals molarity times liters. I have the molarity value, which is 3.5, and now I have the liter value, which is 0.25. The quantity of moles is 0.875. And now, what is the way to convert moles into grams? Because remember that the problem is asking grams. You know how to do it. First of all, we determine the molecular weight of sodium hydroxide. You remember, you know how to do this. I get the grams from the periodic table and round it. And then I add all of this, which is 40 grams. In 1 mole of sodium hydroxide, there are 40 grams. And I know the number of moles, 0.875 moles. I don't know how many grams. Doing the mathematics, we get to 35 grams. And we have solved the problem. At this point, you can begin doing your molarity exercise, or you can continue watching to learn about molality. Molality is also called molar concentration. And as you can see, it's pretty much the same. It's the quantity of moles of solute, but now they are present by kilogram of solution. Molality is called m, lowercase m, and it's moles of solute for every kilogram of solution. Where do we use this kind of concentration? We use it in solid-solid solutions. Do you remember what's the name for this type of solutions? They are alloys. So when the solute is a solid and the solvent is also a solid, we usually do calculations with molality. Let's do this molar exercise together. It says, find the molar concentration of zinc in a 12 kilogram solid solution to make coins, which is composed of 13 grams of zinc in a solid solution with copper. What does it mean? Given 13 grams of zinc, this is the solute, right? Given 12 kilograms of the solution, this is the total weight of the solution. I need to find molality. What is the formula for molality? It's almost the same as the last one. There are moles of solute, but this time you need to convert it to kilograms. And we have it already. We have this value ready. These kilograms of solution are ready. We only need to convert these 13 grams into moles in order to replace it in the formula. Okay, let's look in the periodic table, remember? We need to look for the molecular weight of zinc. It is in here, which is 65. You have to make sure that your periodic table has clear numbers. So, 1 mole of zinc has 65 grams. I don't know the quantity of moles present in 13 grams of zinc. And this value is 0.2 moles of zinc. And the rest is very easy. We just need to replace this in the formula. Molarity equals moles of solute by kilogram. The moles are 0.2 in 12 kilograms, and it equals 0.16 moles per kilogram. Circle your result. Now you are so ready to do your own exercises.